So here we are looking to see if a point that we have is the solution to a 2x2 system. And so what we're going to do is we're going to try the xy ordered pair in the first. If it works, try the second. If it works in the second, we go with yes. If we ever encounter it not working, then we'll stop and say no. So the first one was going to deal with us having 3 times the number minus 4 times the number is supposed to equal 2. First number is going to be x is 6, not 36, and the second one's going to be 4 times y, not 44, but what we come out of here with is 18 minus 16, which is 2, so we're good to keep going. And now we have this other one, y equals 5x minus 26, where we have a number supposed to equal 5 times the number minus 26. First number is supposed to be our x, 6, goes here. And the other number is our y, which goes in the first spot, and that's going to be our 4. Now, you know what I do when I have just a number and it's in parentheses? I drag along my occurrence of the coefficient of 1. You don't want to do that without parentheses because it might look like 14, but here it's perfect. I have a single 4 there. So 1 times 4 gets me 4. This one I'm continuing to go with 30 minus 26. Subtraction gets me 4, and that works as well. Making this a yes because it works in both. It's the only point in the world that would do it. Now we come to this one. I know people have some disdain for fractions. Fractions get a bad rap, but they are more difficult than integers to work with. So we're going to try the first one. 1/3 times the number plus 3/5 times the number, and we're wondering if that equals 3. Numbers going in though are -9 for our x and 10 for our y. So you have to, one way or another, get 1/3 times -9. You can do that on your calculator. 1 fraction 3 times a 9, that's negative. But what I see here is 1/3, it's got a single negative, times 9 over 1. Divide 3 by 3 for 1, divide 9 by 3 for 3. This gets me -3, 1 times 3, with a negative over 1 times 1, so that's -3. Plus, I now have 3 over 5 times 10 over 1. 3 and 5 don't reduce, 3 and 1 don't reduce, but 5 and 10 reduce. Divide 5 by 5 for 1, divide 10 by 5 for 2, so that gets me 6. I have -3 plus 6, subtract for 3, strong on the positive, and that does actually get me a yes. This point is on that line. Now we got the other one. Here's y. That's supposed to equal 7 times x plus 53. Now my y is 10, so I'll put my 10 in there, and my x is -9. And again, when I have nothing but y, you could have just put y, but if I have 1 in front of the parentheses, that justifies, it doesn't just happen, but I can justify why it did. 1 times 10 is going to get me 10. So now that's done being a 10, and this one is -63 plus 53. I go ahead and subtract, and I get a 10. And when I look, -63 is stronger than +53, so my answer is negative. And therefore, when I go for this, I get a no. And if I encounter a no, it is not the point of intersection.